Okay, guys, we're going to go over some definitions first here with this section on inductive and deductive reasoning, and then I'm going to give you guys some examples that we'll look at together in this video, and then follow up with an opportunity for you guys to try some check out my key before you move to the homework. All right, so let's start by kind of putting some definitions here. All right, I'm going to start with inductive reasoning. All right, this is when you find a pattern in specific cases and that allows you to write a conjecture for the general case. So inductive reasoning is when you find a pattern in specific cases and then write a conjecture for the general case. Okay, I'm going to skip to conjecture. Don't worry, I'll come back to deductive reasoning. So conjecture is an unproven statement that is based on observations. So an unproven statement that is based on observations. Now we actually had this word in an activity that we did in our first unit, and we talked about it being kind of like a belief or something. But again, it's unproven, all right? And the way that you're going to kind of disprove it is to try to come up with a counterexample. So this word here below it, a counterexample is a specific case for which the conjecture is false. So a specific example for which the conjecture is false. We'll do a couple examples where you'll get to see this in action. Okay, now let's move to deductive reasoning. Okay, so deductive reasoning is where you use facts, definitions, accepted properties, and any laws of logic to form a logical argument. Okay, so you uses facts, definitions, there we go, accepted properties, and laws of logic to form, let me try to respell that, there we go, to form a logical argument. So let's get into a couple of the laws of logic, and then we'll try some examples here. All right, so I'm not going to have you memorize any names. You'll see if you look in your textbook, underneath deductive reasoning, there's a table that has the names of them. You don't need to know the names, but I do need you to know the general idea of them, okay? So this first law of logic is we're going to write if the hypothesis of a true conditional statement is true, then the conclusion is also true. Okay? So again, we'll kind of come to that here in a moment, but you should hopefully have some good understanding from the first section on conditional statements with P then Q. So the next kind of law of logic is something you probably have seen before. I'll give you an example. So if I come to think of this as separate, right? If I say if P then Q, I'm gonna take out if since that's already there. So P implies Q, all right? And then I say Q implies R, all right? If both of these are true, so if both are true, then we can say P implies R. All right, so this statement would be true as well. Okay, so that's another law of logic that you probably have been introduced to, and if you haven't, that's okay. We're going to use it here in a moment. All right, okay, let's move to some examples. All right, so we're going to look at these three patterns, and predict the next two numbers. Okay, and we're going to describe each pattern in your own words, which could be different than how I used to describe it. So the first one, I have 2, 3, 5, 8, and 12. It looks like if I add 1 from 2, I get 3. If I add 2 to 3, I get 5. If I add 3 to 5, I get 8. Looks like we're continuing to add another number, increased by 1. So this would be 12 plus 5 would be 17. And then we have plus 6 would give me 23. And you could keep going. All right, so it looks like we're adding 1, then 2, then 3. So I'm going to write down the amount added starts at 1 and increases by 1 each time. Okay, so that is my pattern right there. Let's do the next one, part B. Okay, 8, -4, 2, -1, and 1/2. Looks like we are dividing, right, because we're getting smaller. All right, my first thought was dividing by 2, but it looks like we're alternating, right? Positive to negative, positive to negative. So it looks like we have to divide by -2. That's what it looks like we're doing. For all of these, we're dividing by -2. All right, so the next one, 1/2 divided by a -2, which is really times another 1/2 would be -1/4. And then keep going, you would get positive 1/8. All right, so we're getting smaller. And we're alternating with positive and negatives because we're dividing by, sorry about that, a -2. All right, so I'm going to write dividing by -2. Okay, this last one here. 2, 20, 10, 100, 50. Okay, it looks like the first thing we did was we multiplied by 10, and then we divided by 2. Okay, here we go, multiply by 10, you get 100. Divide by 2, get 50. So times 10 is going to be 500, but then divide by 2, and you get 250. Okay, so I'm going to write down that the pattern is alternating between multiplying by 10 and dividing by 2. Okay, let's go to number 2. We have Raj here playing around with multiplying odd and even numbers. Okay, and it looks like based on this table, we're going to make a conjecture, or at least think of a conjecture that Raj could make based on this evidence. All right, so this first one I notice is that we have an odd number times an odd number, which gave us an odd number. The next one is an even number times an odd number, gave us an even number. And then the same thing happened at the next one. Let's look at the one after that. We have even times even is even. The last one is odd times odd is odd. And this one just changes the order here. Actually, it's the same. Even times odd is even. So I guess the conjecture I would make is if you want to get an odd number by multiplying two numbers together, you have to have, or you must have, both numbers be odd. So I'm going to write down, in order to get and I'll say an odd product, both numbers must be odd. That's my conjecture that I'm making. All right, and we'll try to disprove it. Think of a counterexample. Okay, let's look at this one about Jim. It says, last week your friend Jim drank a milkshake at a restaurant and got sick. That's not good. On Tuesday, he wasn't feeling well after eating cheese. Uh-oh. Yesterday, Jim attended an ice cream social and complained of stomach pain. Okay, Jim, I guess we think the logical conclusion is you might have an issue with dairy. So Jim might be allergic to dairy products. So you probably want to lay off the dairy. Okay, what additional piece of information would make you rethink this? So essentially, this is my conjecture. What if I knew more would make me think, oh, maybe he's not actually allergic to dairy. Tortilla chips and got sick. That's not dairy. tortilla chips and felt fine. Okay. Okay, here we go. Buttery pastry and got sick. No, that would go in line with what I'm thinking. It's really the last one. The last one here, this fourth one, if he ate a buttery pastry and felt fine, which has a lot of dairy in it, I would be confused. Okay, let's go number 4. We've got Sam and Davis. All right, so Sam and Davis, we have these following statements are to be true. All right, and then we're going to read it and determine if the statements are a logical conclusion based on the information above. Okay, so here we go. The statements that are true are Sam and Davis. If Sam and Davis are not full after eating pie, they are going to go to Qdoba. If they go to Qdoba, Sam will order a burrito bowl. Sam and Davis are both still hungry after eating pie. Okay, so we're going to assume those are to be true. So here we go. Part A, Sam and Davis had very small pieces of pie. They could have, right, if they're still hungry after eating pie, but it doesn't say anything about the size of the pie that they ordered. So I'm going to say that this is not a logical conclusion, so no, right? And because it doesn't mention the size of pie. Okay, part B. Davis will eat a taco salad. It says they're going to go to Qdoba and Sam will order a burrito bowl. It doesn't mention what Davis will order, so I'm going to say no because it doesn't state what Davis will order. And then part C, Sam will get a burrito bowl. That one is true, right? That's in that second statement there. So this is valid because it states this in statement 2. And then Davis and Sam will get a stomachache. Again, it doesn't say, they're going to Qdoba after eating pie. We know that. Sam is getting a burrito bowl. It doesn't make any mention of a stomachache. I know we had a problem previously that mentioned stomachaches, but this is a separate question. So no, there's no mention of them feeling ill. Okay. Determine whether the statement is true or false. If false, give a counterexample. Here we go. So these are chances to talk about counterexamples. If I have 25 cents, then I have 2 dimes and a nickel. That could be true, but couldn't I also have a quarter? So I'm going to say false. I could have a quarter. I also have 25 pennies. Okay, all birds can fly. Also false. One of my favorite animals, the penguin, is a bird that cannot fly. Penguins. If a number is divisible by 4, then that number is divisible by 2. If I think about all the factors of 4, I should say the numbers that you were to multiply 4 times 1 at 2 times 3 times 4, you're going to get all numbers that are even, and even numbers are divisible by 2. So this one actually is true. Okay, second to last one, sorry. Then we got one more, number 7. 6 and 7, we're done. Sherlock Holmes, always correct, muttered, if a man has no servants, his shirts are wrinkled. If a man has lost his job, he has no servants. Properly order these statements, and what deduction could you make from Sherlock Holmes? Okay, so let's properly order this based on one of those laws of logic we discussed earlier. So I'm going to write, if a man has lost his job, he has no servants. Move this over real quick. Okay. Then, if a man has no servants, his shirts are wrinkled. Okay, so this is that second law of logic I mentioned earlier in the table that you wrote down. that if P implies Q, and then if Q implies R, if those are both true, then P implies R. So in this case, if I assume both of these statements are true, then I could write, the deduction I can make is if a man has lost his job, his shirts are wrinkled. All right, so that's using that law of logic we discussed earlier. Okay, last one, number 7. And then you got someone to try on your own. In each of the following deductions, tell whether or not the third statement necessarily follows if the first two statements are accepted as true. Okay, so in this case, we're going to write, if it does, we write valid. If it doesn't, we write invalid. If you're looking at a leopard, then you see spots in front of your eyes. You see spots in front of your eyes. Therefore, you're looking at a leopard. Well, if I see spots in front of my eyes, I guess I could just be like overheated or dizzy, and I could just be seeing spots or gotten up too quickly. I don't necessarily have to be seeing or looking at a leopard. So I'm going to say invalid for this first one, part A. And then part B, if you forgot your pencil, you may borrow one of mine. You forgot your pencil, therefore you may borrow one of mine. This does make sense to me in terms of the fact that you can kind of go either direction there. So I'm going to say valid. All right, so now you've had a chance to listen to this, to watch this video, to take some notes. I want you to go ahead and try these ones that say try on your own. You can check the key. Once you've finished, then you can check the key. And then after that, you can move to your homework. Good luck.